Okay, guys, this is lecture 11, Lagrange interpolation. So last time we discussed about what interpolation is and the power of using interpolation and when to use interpolation. Right, so interpolation for Lagrange, you know that you are given n plus 1 sets of points. So you can come up with an nth order polynomial, and this nth order polynomial is equals to the function of f of xi. Right, so with the Lagrange, your problem, you are given the x values and the corresponding y values f of x, and the nth order polynomial is equals to f of xi for I is equals to 0 up to n. And the Lagrange interpolation formula is given by the summation of I is equals to 0 up to n of xi and then lix, where lix is given as a multiple of j is equals to 1, j is equals to I up to n of x minus xj, xi minus xj. This is more like a polynomial. Alright, so this is the Lagrange interpolation, and Li represent what we call cardinals. So it's also called the cardinal. And then the cardinals are nth order polynomials. Right, so if I is not equal to j, your cardinal is 0. If I is equals to j, your cardinal is 1. Alright, so this is your example of Lagrange interpolation. So for this one, you've got 1, 2, 3 points. So you have got x, x0, x1, and x2. So your polynomial P2 of x will be given by x naught, L naught, f of x1, L1 of x, and f of x2, L2 of x, because you have got x0, x1, x2. So this will be a summation up to x of x2, L2, x. Right, so where your L1 will be given by x minus x1 minus x2 over x naught minus x1 x naught minus x2. Alright, so take note of something in this polynomial. Something that you should master is that this polynomial is for x naught. So in the numerator, you do not have x naught. It's x minus x1, x minus x2. And then in the denominator, you have got your x naught minus x1, x naught minus x2. And then you do the substitutions. X naught is equals to 1 over 3, 1 over 3, x1 is 1 over 4, x2 is 1. So you can do the substitution. And then for L2, for L1, so this one is for x1. So you can see here on your numerator, you don't have x1. So it's x minus x naught, x minus x2. Again, for x2, for L2, you don't have x2 on the numerator here. So that's how you master this this formula. So here you don't have x2. X2 will only appear on your denominator. This is x2 minus x not x2 minus x1. And then this one will be x1 minus x not x1 minus x2. Then you make those respective substitutions for x0, x2, x1, x0, x1, x2 should get this polynomial. Same again with this one, you should get this polynomial. So your P2 will be given by a f of x0, which is 2 times this polynomial, plus minus, which is plus minus f of x1, which is minus 1, minus 1 times this polynomial, and so on, 7 plus 7 times this polynomial. So now that this polynomial had 3 points, so in the numerator we're multiplying two factors. So let's look at our new example with more points. So this example, we have to use both the Newton's interpolation and the Lagrange method. So the Lagrange method for this one, we will be multiplying more than two factors because this one has got 1, 2, 3, 4, 5. So now that this is 5, so it means that you'll be multiplying 4 factors on the numerator and 4 factors on the denominator. And those 4 factors should not contain, if you are doing for x0, they should not contain x0 on the numerator. That's the only difference. So you can practice the Newton's-Raphson's method, the Newton's interpolation method, satisfy yourself that you get those values, and then the polynomial will be given by this. And then for the Lagrange interpolation, this is L0, so L0 should not contain the value for, on the numerator, it should not contain the value for x0, where x0 is 0, so it should not contain 0. So 0 there, you don't have a 0. So this is x minus 1, x minus 2, x minus 3, x minus 4 over 0 minus 1. So the x0 will only appear on your denominator there. Instead of subtracting from the x, you are now subtracting from x0. Same again, your x1, which is equals to 1, should not contain 1 on your numerator. Your 1 will come in place of x there, which is x1 on your denominator, and so on. Make sure you master how you do this. So this is how we come up with this is how we perform a Lagrange interpolation and find the respective polynomial. Thank you.